Hi, welcome to the next session. In the last session, we just had a look on the basic understanding of what Pytorch is or why Pytorch is getting popular over a period of time. Now, to start further, there are certain things, certain terminologies that you need to know. Like, for example, the very first terminology that you need to know is the logic of computational graphs. Now, PyTorch is a brilliant or excellent platform which offers dynamic computational graphs. That means it basically converts stages into the form of graphs or into the form of sort of flowcharts. Okay, so it offers you dynamic computational graphs. So, with the help of PyTorch library, a user can change them during runtime. Means while the code is running, you can change these graphs at any point of time. That is why they are known as dynamic computational graphs. So now this particular feature of that a user can change them during runtime as well. So it is highly useful, particularly when a particular developer or has no idea how much memory is required for creating a neural network model. Now, neural network model ideally requires a lot of memory, though it is totally dependent upon the size of the model that you are expecting to draw on. But since normally at earlier stages or initial stages, it's very difficult to make any prediction with respect to the size of the model and or the requirement of the memory according to the size of the model. So a user need to change them at any point of time while the code is already running. So that is where PyTorch acts beautifully because it offers you the formation of computational graphs in a dynamic way. So there are three important terminologies that you need to understand when we talk about PyTorch. The first and very popular word is the word tensor. Okay. So all of you must have heard about the Tensor library. So Tensor is simply a n-dimensional array. Okay, it's nothing. It's an n-dimensional array which runs on GPU as well. Okay. Then another word is variable. Now variable is basically a node in a computational graph. Okay, so since a computational graph consists of nodes, so the node in a graph is known as a variable. So the ideal objective of a variable is that it stores data and the value of gradients. Okay, so gradients are there when we go with backward propagation. So we'll understand about it in detail later on, what all this is all about. But variable is simply a node in a computational graph, and the ideal objective is that it stores the required data and the gradient values. The third important terminology that we should know is the module. Okay, now this is that layer of your network which will store the state or the learnable weights. Okay, so when we talk about a neural networking model, the concept of weight is very important. Again, we would be dealing with this thing later on in detail, in very much detail actually, that what is the concept of weight while we are drawing neural networks. So for storing these learnable weights, the modules are used. Okay, so tensor, variable, and module. These are the three very specific terms. Tensor is simply an n-dimensional array which can run on GPU as well. Variable is ideally considered to be a node in a computational graph whose job is to store data and the gradient values. And module is a that layer of a neural network which store the learnable weights or the weights learned during the process of neural networking. So tensors, as I said, they are just similar to if you compare in terms of NumPy. Okay, so tensors are similar to NumPy arrays uh, with an addition that they you can also use them on a GPU to accelerate the computing. So in case of complex and complicated tasks, GPUs are required, or high speed tasks GPUs are required, and So to work with GPUs, NumPy is not possible. NumPy cannot work with GPUs. So therefore, tensors are used, and that is where they provide a additional benefit. Okay, so you can use tensors on a GPU as well. Ideally, we can say tensors are just similar to NumPy arrays, the way we define NumPy. Okay, so NumPy is one of the very strongest libraries when it comes to numerical computing in Python. Why PyTorch? So if we try to gather a few important points here. One, it offers a strong GPU support because it's very important in case of complicated and complex tasks. GPUs are definitely required. So strong GPU support is a very additional advantage which the PyTorch offers. Then many algorithms which are of great use to us when we are doing neural networking or deep learning are already implemented, so you don't need to implement them separately. Then it allows automatically differentiation. Differentiation is again very important part of neural networking, and it's similar to NumPy. Okay, so when we talk about neural networking, when we talk about deep learning, we talk about computer vision, image processing, and so on. Uh, the data is ideally present in the form of arrays. Okay, in the form of integers, in the form of numbers. So uh, NumPy, since NumPy is not viable to run on GPUs, or it cannot be used for that level of complex or complicated processing, so therefore PyTorch tensors uh, act as a great replacement to that. Okay, so that's where the use of PyTorch is there, and that's how it offers great flexibility, speed, and super processing power to enhance your deep learning or neural networking. Now, we only need two imports at this stage. One, I would like to import the print function, okay, because that is not inbuilt with the torch. So from future, I will import the print function. And the second important import that I need is to import the torch, okay. So like we import numpy as MP, okay. For example, if you want to work with numpy, so you have to import numpy as np. Np is a abbreviation or a context for running numpy library. Okay, so you don't need to tie numpy again and again. Np is good enough. In the similar way, when you are working with pytorch, you need to import torch. Okay, so torch acts as a context for pytorch, as simple as it is. Now since we'll be working with matrices, because when we talk about computer vision, image processing, and all this stuff, the data is ideally reflected or designed in the form of matrix only. Matrix is basically simply acts like a table with columns and rows. So the data is majorly available in that format only. So that's why we are talking about matrices. So when we talk about an uninitialized matrix, uninitialized matrix means it does not control any definite known values. So whenever you are declaring an uninitialized matrix, that means you are not telling or you are not putting any known or definite values to it. You are not giving any definite values to it. So in that case, whatever values were already there in the allocated memory will appear as the initial values. Okay, so either you define the values which a matrix needs to take. If you will not define, then in that case, whatever values are present in the allocated memory at that particular time will be shown as an output, simple, or will be shown as the initial values. So that is what the uninitialized matrix means. Matrix simply means you want to reflect data in the form of table with rows and columns. And since when we talk about deep learning or when we want to apply the neural networking, the majority data or 99% or greater than 99% of the data is present in the form of this format only. So when we talk about an image, okay, you want to process the image or you want to do some processing on image, then ideally the image data is has to be represented in the form of matrix only. Okay, so the concept of matrix is very important. That is why the concept of numbers is or arrays is very important when we talk about deep learning or the uh, application of deep learning with the help of PyTorch library. Okay, so in the next session, we would be having a small comparison, or we'll take few examples to compare PyTorch with NumPy. Now, since we say that the PyTorch is an extensive advancement of NumPy when it comes to applying deep learning or neural networking or performing complex or complicated tasks. So once you will understand the difference, or once you will be able to compare the functioning of NumPy and PyTorch, you will realize that it's almost similar. So whatever commands we used to run on NumPy, the similar sort of commands will run in PyTorch as well. Just a little bit change is required in the form of context calling. Like for example, when you are applying NumPy library, you use NP as a context. So definitely in Torch, the same thing will not happen. But the overall conceptualization of writing the code will be almost same. Okay, that you will see when we'll go into that. Okay, so in the next session we'll start off with the comparison of the PyTorch with the NumPy. Okay, or the matrix formation using PyTorch and the matrix formation using NumPy. So you'll automatically realize that what are the similarities and where the difference exists. So till that time, keep practicing, and thank you so much.